Hi everyone, I am Yuanyuan Zhou. Today I'd like to talk about an issue that is often invisible, yet touches millions of lives around the world, lead poisoning. Even though lead is one of the oldest environmental toxins known to humans, its impact is far from being a problem of the past. In fact, recent public health reports and real-world incidents remind us that lead exposure is still present in our homes, our communities, and even in the food that children eat. On this slide, let's talk about what lead poisoning is. Lead poisoning is due to the accumulation of lead in the body, typically over months or years, resulting in toxic effects on multiple organ systems. Lead poisoning is a significant public health problem around the world, especially in children and low-income communities. Lead is a widely used but poorly degradable pollutant that can accumulate in the environment for a long time, contaminating soil, water, and air, and is almost everywhere. Lead exposure causes a total loss of 765 million IQ points in children every year and led to 5.5 million deaths from cardiovascular disease worldwide in 2019. Those who are affected by lead poisoning may experience fatigue, headache, irritability, severe abdominal colic, and constipation. The New England Journal of Medicine once published a recent review on lead exposure. Although lead exposure among the U.S. population has dropped by more than 95% since the 1970s, the body's lead burden remains 10 to 100 times higher than in pre-industrial times. In 2000, Diels Goldries had already described the symptoms of overt lead poisoning. When the blood lead concentration exceeds 800 microgram per liter, acute lead poisoning can cause convulsions and even death. Besides, the most characteristic sign of chronic lead poisoning is Berson's line, which is a blue line of lead sulfide along the gingival margin. It is a thin blue back line of lead sulfide deposited along the gingival margin, typically appearing where oral bacteria produce sulfide that interacts with circulating lead. In recent years, public awareness of lead poisoning has increased a lot. However, it is still a problem in public health. This is because lead residues from sources such as the deposition of leaded gasoline in soil and emissions from incinerators still persist. Because of its widespread environmental presence, long-term health consequences, and impact on children and disadvantaged communities, lead poisoning continues to be a critical and preventable public health challenge. Next, I will discuss lead poisoning from our perspectives, describing how it affects different systems of the human body. When people are exposed to lead, they may have multiple organ damage. The most significant damage from lead poisoning occurs in the nervous system. The neurodevelopmental effects of lead exposure was first reported by Byers and Lord in 1943, who observed persistent behavioral and cognitive impairment in children recovering from lead poisoning. Lead can easily cross both the placental barrier and the blood-brain barrier, and its damage to the developing central nervous system is particularly significant. During the early stages of brain development, neural precursor cells undergo extensive proliferation and differentiation into neurons. Lead can interfere with this process by inhibiting neuronal proliferation and differentiation. In addition, lead poisoning can cause protein kinase C, that is PKC, to prematurely translocate from the cytosol to the cell membrane, disrupting the maturation and development of brain endothelial cells. Lead may also accumulate within endothelial cells, directly damaging the blood-brain barrier and impairing synapse formation. Lead exposure is a risk factor from preterm birth at concentrations commonly found in pregnant women. In a prospective Canadian birth cohort, an increase of 10 microgram per liter in the blood lead level was associated with a 70% increase in the risk of spontaneous preterm birth. For women with a secrete vitamin D level of less than 50 nanomolar per liter and an increase of 10 microgram per liter in the blood lead level, the risk of spontaneous preterm birth was increased by a factor of 3. This is because lead can bind to calcium channels in the brain, disrupt neuronal signal transduction, and interfere with neurotransmitter release. Well, when it comes to the skeletal system, most of the lead is contained in the bones, and lead can replace calcium in bone tissue, causing rarefaction of bone. Approximately 70 to 95% of the lead in the body is stored in bones. Bone acts as a long-term reservoir, releasing lead back into the bloodstream during pregnancy, menopause aging, or bone turnover. This is because at the cellular level, lead reduces the expression of key markers such as ALP and COL1 and disrupts the WNT signaling pathway, thereby posing a threat to bone health. This condition leads to pain and limited mobility, placing a significant economic and psychological burden on both individuals and healthcare systems. Moreover, lead exposure also causes cardiovascular dysfunction. Lead poisoning can cause hypertension by inhibiting endothelial repair. In addition, lead can directly affect smooth muscle cells, suppressing their autonomous contraction while increasing muscle tone. The underlying mechanism is that lead exposure induces the generation of ROS, which trigger oxidative stress, impair endothelial function, and promote inflammation. Lead exposure also inactivates nitric oxide, increases the formation of hydrogen peroxide, and inhibits endothelial repair. When it comes to renal system, lead will always accumulate in the proximal tubules of the kidney, causing tubular damage and reducing filtration capability. Chronic exposure contributes to progressive kidney disease. Lead exposure is a risk factor for chronic kidney disease. Among participants between 1999 and 2006, adults with a blood lead level exceeding 24 microgram per liter were 56% more likely to have a reduced glomerular filtration rate than persons with a bleed lead level below 11 microgram per liter. In a prospective cohort study, the risk of chronic kidney disease was 49% higher among persons with blood lead levels exceeding 33 microgram per liter than among those who with lower blood lead levels. Moreover, we must know that lead poisoning does not affect organ systems independently. Instead, its toxic effects create a cascade of interactions among the nervous, skeletal, cardiovascular, and renal systems. Well, for example, the skeleton stores approximately 70 to 95% of the body's lead. During periods of high bone turnover, such as pregnancy, aging, stored lead is increased back into the bloodstream. This secondary exposure elevates blood lead levels and re-amplifies toxicity in other organs. Besides, as for the cardiovascular system, lead-induced kidney injury reduces glomerular filtration rate and disrupts sodium handling and RAAS regulation. This leads to increased peripheral vascular resistance, volume retention, and directly contribute to hypertension, which is one of the strongest documented cardiovascular outcomes of chronic lead exposure. Let's talk about the case of lead poisoning. In July 2025, a collective lead poisoning incident at a kindergarten in Gansu Province, China, drew widespread attention. Since the spring of 2025, many children had developed abnormal symptoms such as leg pain and black spots on their gums, and were subsequently diagnosed with elevated blood lead levels. Investigation revealed that the snacks served to the children contained excessive levels of lead caused by the illegal use of colored paint as a food additive by the kindergarten. This heartbreaking incident serves as a stark reminder of the continuing threat of lead poisoning and the severe harm it can inflict on public health. Now that we've discussed the health impact of lead, let's move on to what we can actually do to prevent and manage lead poisoning. First, screening plays a crucial role. Screening high-risk children and adults is strongly recommended, especially in communities with older housing, industrial population, or known environmental contamination. However, while screening can detect the problem, it does not eliminate the source. Ultimately, the real solution is to identify and remove environmental lead wherever it exists. In the United States, that means eliminating lead acid batteries, replacing lead service lines, banning leaded fuel, reducing lead in foods, abating lead paint in older housing, and further reducing lead-contaminated soil and other legacy sources. In conclusion, lead poisoning is entirely preventable, but only if we take action. By identifying sources and enforcing environmental controls, we can protect children, families, and entire communities. Lead has harmed public health for decades, but it doesn't have to be part of our future. Thank you. These are my references.